What do we use the blower for? Come on, Gene. What do we use the blower for? This one's on Gene.
To heat the air.
Well,
blow
think
it?
about that. To blow the air. Okay, I'll give you that one. I was going to give you a half point, but you saved yourself. You get a full point.
Okay.
We have a heater. Then we also have a blower. And what this blower is looking to do, our drum, our horizontal drum, is basically an auger or a drill bit that's wrapped in a perforated screen. Excuse me, as it rotates, we have heat elements on one side and we force air on the other side. We have a divider that divides the cabinet into those two sections. On this section, that positive air goes through the food or the corn and creates a fluidized bed or agitates the corn. Oil poppers have mixers. If you're doing it at home, you're shaking it. Here we're using air to fluidize the bed of corn. So it's very important to have the correct air pressure to give you proper agitation. That proper agitation, that air then travels through the drum, goes back over the top, collects more heat, and comes back through the center cone into the blower and recirculates. We're not drawing in cold air from the outside. All we're doing is reheating the same air, which makes us very efficient. Well insulated, low energy, and we're able to also hold a very stable cabinet temperature. After you reach temperature and you're running, do you notice that it stays at temperature maybe plus or minus 1 degree?
Yeah.
It's good, because that could be another reason. But that's another indication. If you're overfeeding this machine, it'll struggle to keep up temperature. With gas burners, with the larger machines, it's not so much. With electric, you're very limited. It can't handle too much. It can't go over.
It always overshoots it a little. It always overshoots it a little bit.
Awesome. That's what I wanted to hear. Why would it do that? Anybody? Joe, go ahead.
Why does it overshoot?
Joe.
Yeah.
Kinetic energy.
Well, that's actually seconds or something. So he's right. What it's doing is, and actually this temperature controller in a simpler form, is auto-tuning itself. It's trying to gauge how much energy it needs to release to hold that temperature. So it's got a PID, it's proportional, it's saying how much heat it has to give and how much temperature rise. So that's why it does it when you first turn it on to air. How much energy do I need to heat up this air? Then you put corn into it, what happens? The
It
temperature
goes down.
drops, man. And now this has to, once again, go and auto-tune itself and say, how much energy do I need to release to keep this cabinet at this temperature with this load going through it?
Okay.
So now it takes 5 minutes, it's stabilized again. Then you shut off the amount of corn, what happens? It jumps up again. And that's because it had been giving you enough energy